Good day, everybody, and welcome to our webinar today. I'm Denis Gagné, CEO and CTO of Tritech.
And I'm John Sverbely, CMIO at Tritech.
We're happy to welcome you to this webinar. Today, we're going to be talking about clinician-centric data and AI integration into the context of healthcare. So let's get going right away. So when talking about data in healthcare, there's a lot of discussion about data that is very generic in meaning, but there are many different facets to using data in the context of healthcare. And today we're going to tackle a few of them, not all of them, there are many more, but we're certainly going to look at how clinicians, when they're using data, actively doing their work, are using data and how their thought process of using that data influence how data comes into play. We're also going to look at how data can provide meaning. So for example, if I tell you weight is 25, what does that mean? You know, we have to understand. There's all kinds of different things, and we're going to talk about concept and semantic lifting to use data. We're also going to talk about interoperability, in particular, how we can use structured data in interoperability. And finally, we're going to look at how data can be used in AI in the context of healthcare. So these are the four topics of today. So plenty of topics. We'll try to give you some insight on all those four fronts. Now, when talking about data, there are many different types of data that are available, and we may not think of that in particular in general, but there are very important distinctions. So there's structured data, which is usually the data we find in data stores and databases. Then there's unstructured data, which are the data we find in documents and images and those kinds of data information pieces. And then there are time series. Time series are a sequence of data points that are continuously coming true that informs us about an ongoing situation. There's a notion of interdependent or relative data, and there's a notion of raw and normalized data. So these are all kind of types of data that we should be aware of and how to deal with them. So our first topic is about the clinician thought process when using data. So I'll let John discuss that with you.
Thanks, Denny. Let's get started looking at the current situation in healthcare and how clinicians look at data. Now, one question you might ask is, why do we care about data? And the main reason is that everything that's done in healthcare is dependent on data. And while patient care may be the center of the focus of clinicians, when we get to data, data is really clinician-centric, because clinicians are the ones that order the data, they're the ones who use the data, and they are the ones who justify its use. So data is intimately involved with the clinical practice of medicine. And the data is used in a number of contexts. It may be used in diagnosis, it may be used for prediction, may be used for responsive therapy. So everything that's done is dependent on data, because otherwise you just pull it out of the air. So we're evidence-based in practice, hopefully. And so we use data quite a bit. And if we go to the next slide, please. When we look at how a clinician looks at data, they currently answer a number of questions. Sometimes they ask all of them, sometimes they don't ask any of them, and sometimes they ask questions at various levels of complexity. Now, one question they may ask is, what data do I need for my goal? What data is available? What data is relevant? Data is accurate, precise? Is it consistent with the clinicians, the clinical appearance of the patient? And do I need to do anything to the data to make it more relevant? Underlying all these questions is, do I trust the data? Trust is one of the most important parts of healthcare. And if a clinician gets data through FHIR or some other mechanism, if they don't trust the data, they'll just order a new test if they possibly can, because that's what they need at this moment to treat the patient. And if we go to the next slide, please. If we take those steps and try and present them in a process, this is what you can generate. And it may be far more complex than people realize because there's several things going on. But the whole idea is that the clinician is the gatekeeper for the data. They want to be sure that only data that passes muster is utilized. So it's a kind of primitive data cleansing process. And so that currently is what we have. And we all know that healthcare today has several issues that need to be improved upon. So I think for the rest of the seminar, we're going to be looking at what are ways that we can improve how data is utilized and take it to the next level. Next slide, please.
So, John, are you telling us that basically this thought process that the clinicians are going through takes place whether there's automation or no automation?
Well, this is basically yes. This is currently what happens is that if I get a lab result, then I want to say, go through the series of questions. Is it relevant to what I'm doing right now? Do I trust the data? And so if it's automated, I may not actually see the data in a fully automated process. So there's a need for that level of cleansing, and would be something you would need to build into automation to make sure that any decision that I'm making is based upon the best data I can possibly get.
Great.
Now, let's go to the next section where we talk about concepts and semantic lifting of data. So we have our current state, and in many ways, data in healthcare suffers the problems of any language. And this is an issue you get into translation software, where many words might have 5 or 6 meanings, and it's all dependent upon context of the situation that the translation that you get may come the way it is. And the ambiguity can come in from words having different meanings, different contexts. A single analyte, such as LDH, might be determined by 3 or 4 methods, each of which has a different set of units, which can introduce a level of confusion. And then finally, a single concept may be referenced in different ways. And as an example here, it's diabetes may be referenced based on an ICD code. That might be based upon elevated fasting glucose, insulin dependence. There's various ways that the concepts may be translated, and this can lead to a number of problems, as we can see in the next slide. So the goal that we need to strive for is to reduce ambiguity, because ambiguity makes things inefficient. They miscommunicate. You can result in misuse of certain things. You may get misinformation creeping in. And the way to approach that is to disambiguate. And you can do that by a number of techniques, such as making use of terminology, concept maps, and business rules. The last indicating how the data is actually used, putting it more in a usage context for people to understand. Next slide, please. And so this indicates the process that we need to do is we have a narrative text or data source. What we need to do is process this in some way so that the various elements can be pulled out and then manipulated in various ways, then clarified. And then that data is what's set to the processes and decisions to make sure that everything is as simplified and understandable as possible. Next slide, please. Now, when we talk about concept maps, this is an example of a knowledge entity model where this shows the basic concepts and the relationships that exist in the area. And the example here is acute suicidality. But it shows all the terms and then the terms that have a relationship to it and what type of relationship that has. So this gives you an idea of where concepts are in space, so to speak. And next slide. Each of the terms that is in this map can then be further clarified by providing all the elements that are needed to provide context. So that might be telling what type of data is used in the particular application, the textual understanding, synonyms, the linkages, the codes, the data sets that might be involved. Those are all shown on the left. And on the right, we have examples of rules where each of the rules describes how the actual how the actual clinical care is utilized. And you notice that if you look at the rules, each of those words have different colors, and those reference to linkages back to the actual terminology. So by doing this, you can have a sentence and then have a user understand every word and relationship that is there. And this is very powerful because it allows people to easily read something, and then if they have a question or something they don't quite agree with, you can have a chance to resolve it before it actually goes into action. And I believe, Denny, next section goes to you.
Yes, but before we switch, so fundamentally, we're doing all this work or trying to disambiguate from just having data and a particular data point to get to a higher level concept, and then make sure that that concept is aligned with the data and aligned with the meaning of what we're doing. I think that's very important and very powerful because every organization have their own vernacular. They'll talk about a particular concept or a particular element in a particular way, and to adjust the language, the concept, the nouns to that particular context is very important.
Yeah, because you definitely, standardization is the key to moving forward. And by standardizing the data, you can standardize utilization. You bring up the excellent point that in an organization, you might have multiple players. It's not just one person building it. You might have multiple people, and they all have to be on the same page so that when I'm editing something or I'm modifying something, I know what the foundation is. Otherwise, you're just winging it each time. And then after a series of winging incidents, God knows where you are in where you want to be.
Okay, so let's move on to our third topic of today, which is about structured data for interoperability. So one particular standard that exists, hopefully everybody on this webinar is aware of it, is the HL7 Fire standard, which is a standard for capturing structured, unstructured, time series, interdependent, and relative data in the context of healthcare. So it is a standard that is tailored and adapted for the context of healthcare. And it's a very important standard by now because certainly in the US, it's been mandated by the government to be used. And now we're seeing it being applied in many different countries around the world. If not directly used, certainly looking for some equivalency and some mapping into it. So certainly if you're interested in data and you're in the healthcare industry, you should be looking at the FHIR from the HL7 group.
And that's very valuable from the perspective of breaking down silos of information because it improves the exchange of information.
So an example of unstructured data are patient notes. Pretty much every clinician, nurse have to enter some patient notes at some time. And those patient notes are usually entered as natural language notes that are entered into the patient record. So the creation of these notes can become a source of problem because it is time consuming. One of the problems that may come is people to shortcut things will copy paste the notes from a previous encounter and paste it for the new patient by changing the actual value. So it is something that is time consuming, but very important to understanding what's going on during the encounter or the particular diagnosis in this context. So there's technology now that allow us to improve the patient notes. In particular now, a lot of new AI systems are coming with ambient note taking. So basically, there's an AI listening to the encounter between the clinician and the patient, and this AI will provide a summary of the discussion. And when this AI is properly trained and tuned, it can actually output a structured rendering of what really happened. So these notes are very, very core to healthcare, but we still are at the beginning on how we can really exploit them efficiently into the context of a digital environment.
And there is a problem with the current note takers in that they can have hallucinations and provide notes. So even now, while it reduces the burden, it doesn't completely remove it because the clinician has to review what's posted to make sure it fits the context.
Yes, and as you know, I'm a very strong proponent of human in the loops. Whenever using AI, I think humans should be in the loop at least at some point to validate and accept what's been done. We shouldn't be doing this blindly. So another standard that's been developed is called the Shared Data Model and Notation. It's a standard from the Object Management Group, the same group that created the Process Decision and Case Standards, BPMN, DMN, and CMMN. And this new standards, SDMN, allows you to create a visual structure, a visual logical structure of your data. So that is very powerful because it provides us with a single logical construct to use in the context of processes, in the context of clinical decision, and in the process of clinical cases management. So this gives us a single view that can be augmented with the semantic part you mentioned before, John, with all the disambiguation and the terminology. So now we have a very single view of everything. And what's very interesting and very powerful is that this standard is totally aligned with FHIR, which is the standard from HL7 we mentioned before. So you can have your FHIR data structure that is captured with SDMN, and all your entries can be structured logically, used in your various clinical decision process and cases. So that was basically just a quick intro to how structured data and standards can be involved in healthcare. Naturally, we have 4 different topics that we're tackling today. So we're doing a quick overview and give you some insight. We're going to be happy to discuss those into more detail in the question periods, and happy to address any of your question on those topics. So on the topic of data and AI, naturally, we're in 2024. In 2024, you cannot do a presentation or a webinar without talking about AI. So here's our token AI discussion. So what's very interesting is that when people talk about AI, they talk about the top portion there. Basically, they think you take data, you put it through some AI, and you get some value. The reality is far more complex. It's not as simple as it seems like that. So there's a lot of work, a lot of engineering that needs to take place. with the data at the source, with the engineering of that data, and with the modeling that uses, and then the operationalization of that data also required a lot of effort. And so while it is nice to promote, hey, give me your data, I'm going to put some AI or you're going to get some value. Behind the scene, there's a lot of work that needs to take place, and we have to make sure that work takes place, because that's what's ensure that we create secure, explainable, and accountable system using AIs. Now, again, talking about AI nowadays, everybody is saying AI this, AI that, but really what everybody is referring to is the current elephant in the room, which is generative AI, which is a very powerful source of AI, but we have many different kinds of AIs. And when you're looking at using AI in the context of healthcare or any other context, you should be looking at using the right kind of AI for the right purpose. Generative AI, any of these large language models are very powerful. They do very interesting thing. But if I have to compute 1 + 1, we know how to do that in the hardware. I don't need a large language model that will do millions of computation to give me the results of that. So we should be focusing on actually using the right AI for the right task, so we gain all the benefits from these.
And I understand that about 80% of AI projects fail, at least in business. And one of the reasons for that is they misapply the AI engine that they use. You have to pick the right tool for the right situation.
Yeah, they're referring to that RAND report that just came out not too long ago, that basically surveyed and showed that most of these failures are done because of a urgency to take the new shiny thing and apply it to anything. So we should take the time to really evaluate the problem, find the best solution for the problem. So solving some clinical problems with AI, there's certainly a lot of power with making predictions. Predictions are useful to inform the clinician into their work. So we have standards for that too. PMML is a standard that will allow to support various kind of predictive AI and integrate them into your workflow. When it comes to communication, certainly generative AI is where it can be very useful. So supporting any communication, whether it's translating or explaining or summarizing, that's really where large language models are useful, and I highly recommend their use in that context. We also have AI models that will do image recognition that are heavily used into interpreting MRIs and X-rays and different types of various imaging. We have the capability of using AI to handle large amount of data. As human, when we have a stream of data, we usually pick and choose to interpret because we're overwhelmed, where an AI system can actually gobble an awful lot of data and give us some help. Certainly also, and everything that has to do with automating repetitive tasks, that's where we can use AI. And also another aspect that hopefully we're going to be developing more and more, which is everything about orchestrating diverse clinical teams, everything that has to do with care coordination, which I think is the next holy grail for automation and AI in healthcare. It's care coordination.
Now, when we talk about AI, one of the common concerns people have is, am I going to be replaced, or am I going to become insignificant? It's basically they're viewed as a threat. When we look at that list of things that Denny just showed, most of these things are things that we should welcome, because we spend a lot of time digging into useless things or deal with things that we can't possibly understand. And I think like dysmorphic features in infants. There are programs now that will, show the picture of a baby, and you can get a list of what conditions to look for, and that's a godsend in practice.
And so, as I was mentioning, the huge data that is available, we have all kinds of capability that we can exploit with AI for discovering, searching for new insight, improving the care with higher sensitivity and specificity, as you just mentioned the example, John, and also in terms of automation to cover more or less of the details for the different patients or population there. Now, using AI has its challenges. I think we've been hearing more and more of the challenges over the last year. But certainly, I would say AI is the poster child for garbage in, garbage out. I know we've been saying that in computer science for many years. You know, if you provide me garbage inputs, you're going to get garbage output. But certainly, in the case of AI, I think it's more than evident. Because of that, we need clean data. So clean data is a must in the context of AI, and certainly in the context of AI in healthcare. There are many ethical issues that we have to deal with, copyright and ownership of data as well for training those AIs, and also ensure there's no data set bias or no bias in that data set. Although I've been arguing recently that there's two kinds of bias. There's a bad bias, but there's the good bias. So there is bias that we want, and that bias is so that the decisions are made based on our value and our intention, as opposed to decisions that are made on unintended context.
And I think the whole issue about clean data, that reflects back to the second part of the talk. We talk about standardizing data. By having standardized data that people can understand, your data becomes better. And that's something which really becomes essential when you start getting into AI.
Yeah, so one of the things that needs to take place is what's called data cleansing. So health organizations do generate a lot of data, but not all of it is accurate, organized, or well-formed. We know that when you're looking into a record, there's data entry that are marked as errors or data entries that are not attached to the right observation or condition. So you have to make sure when you start using data for healthcare context, whatever the source is, that you do some cleansing, which means some fixing and removing incorrect and corrupted values, duplicates, and making sure that your data set is aligned with the intent. Now, data efficiency is what makes everything very important here. Not having the right data when needed is very problematic. Interrupting the process to obtain data can be very disruptive and sometimes life-threatening if the right data is not available at the right time. Some tests are ordered unnecessarily. There is a need to create a protocol for the collection of data that is needed. And this is important not to waste the available information. So basically, we're pushing for this kind of clinical guidelines on how things are done and how the data is used. So we use the right data at the right time for the right purpose. So everything needs to be contextualized. So data is not everything. We need to contextualize that data, get the semantic of what it means, and use it. So fundamentally, we've been talking about this progression, moving from data, pure data that may be interpreted in many different ways, providing some structure of that data so that we have a data structure, so that we have a common schema so we can do computable data. And then we add value to that by adding context and adding event awareness and metadata so that we're now in an information. So data and context is information. So we can now do information automation. And then we can take all the data and move it with disintegration and add case and decision in AI so we can have workflow and decision automation that leads us to a decision-centric orchestration in the healthcare environment. So this is the shameless plug of Tritech at the end. Tritech offers an architecture that gives you that decision orchestration layer in the context of healthcare. bringing in different kinds of AI, predictive AI, generative AI, symbolic AI, in the context of workflow and case automation, connecting to whatever user interface that you may have and whatever data source that you may have, whether that data source is a data structure or a stream of data events. So our conclusion very rapidly, we showed you 4 different aspects of using data in the context of healthcare. We've introduced a BPMN notional model of the clinician thought process. We've introduced knowledge entity and concept models along with business rule to help with semantic lifting and disambiguation of the data. We've introduced SDMN combined with FHIR to give you a more structured interoperability of your data. And we've discussed briefly the usage of AI in the context of clinical usability. And that is our presentation for today. We're out of time, but we'll be happy to stick around and answer a few questions. I see there was a lot of comments and questions going on. So if you have a particular question you'd like to ask us, I see a lot of comment reinforcing our presentation. Data semantic is important. Semantics are contextual. Standardization is also the foundation for the quality of construct. Then there's one question: how does SDMN differ from entity relationship diagram? It is somewhat related, but SDMN is really about the logical structure. So it doesn't, entity relationship diagrams were more created for manipulating data. SDMN was created to provide a logical data structure to the conceptual elements that are used in process, case, and decision. So there's many interrelationship and that can be done with entity relationship diagram. And then a question: how does Tritech help with orchestration of knowledge, especially with respect to shifting data semantic model? Tritech actually does orchestration at many different levels. So we can orchestrate the actual data itself. So we can do all the ETL orchestration of the data. We can also work at the concept level, where we're dealing with more with abstract concept, like, for example, diabetes, which is a concept. But we ensure that we disambiguate it with proper terminology, coding, and concept mapping, and then orchestrate this into the context of clinical decision or clinical decision processes. Does Tritech offer a SDMN function? Yes, SDMN is a new standard. Tritech already has an SDMN modeler that is part of the Tritech suite. From Raquel, how do you deal with data protection for sensible data in AI? That is actually a very good question and a very important point. Everything that has to relate with sensible data needs to be manipulated in the context of its use. So for particular usage, the sensible data may be used. Other usage, it's not appropriate. So it's through the modeling of how and which data you use in which context that you can make sure that only the proper data is used in there. And there's lots going on, but I think we're a little bit too much out of time. We'll be happy to answer all the other questions offline through emails. And thank you very much for your attention, and hope to see you in our next webinar.
Thank you very much.